Assalamualaikum to Dr. Nirda. My name is Iziana binti Ismail and she is Aizat Fatima binti Maidin. We are from Group D who would like to present the simulation modeling and analysis of petrol station.
Okay, next is the presentation outline. So in this slide presentation, we are going through introduction, methodology and data analysis.
The background of the study: critical decision making has become a serious problem to top management in different sections of industry, including service industry, due to many limitations in time, cost, labor and different sources of energy. This is cited by Muazzami, Galankashi and Karimi in 2015. As simulation modeling includes an essential set of mechanical device and technique for the effective usage of computerized manufacturing as well as service industry, since it takes into consideration the experimentation and validation of item, process, and system planning and setup. Increasing in population has forced enterprise to increase their capacity, and this has made companies size larger. The existing operating system should be analyzed regard to flexibility, waste, hidden costs, and this make the question of how the process can be analyzed without stopping it.
Okay, proceeding to the problem statement. Nowadays, the demand of people going to petrol station to refuel their automobiles for work and personal purposes keep increasing day by day. It becomes a serious issue to many petrol stations and lead to force petrol stations to look for solutions to increase their production as well as improving their performance. So according to the statement of manager in one of the petrol stations in Changlun, Kedah, they would like to examine its operation for potential improvement. So this situation happens because of the increase in the number of customers recently. So to optimize customer arrival, the system becomes out of control. This issue facing by the manager of the petrol station can be resolved by evaluate the performance measure of the present operating processes using simulation, which include potential peak hours and existing of irrational customer behavior.
Next is the case study description. Caltex North-South Highway petrol station service system was considered as the simulation modeling system. The petrol stations are classified into 5 stations. The station 1 is the platform, station 2 mini market, station 3 refilling counter, station 4 fuel pumps, and the last one, station 5 is pump tire. Figure 1.1 show that the Caltex North-South Highway layout. The 2 cashiers are located in this petrol station. The one is perform payments for customer who only want to refill their cars, and the other one is located inside the supermarket and perform payment for shopping in addition to payment for the fuel. Okay, the figure 1.2 show the flowchart process map.
Okay, next are the research questions. So the research question 1 is what are the waiting time of customers spent at the fuel pumps in petrol station? Second is what is the utilization of fuel pumps machine and the workers at the petrol station? The third one are what are the options available to improve the petrol station operating process in order to solve the problem faced by the petrol station? So research objective, first one is to determine the average waiting time of customer at fuel pumps in petrol station. Second one is to identify the utilization of each fuel pumps and the workers at petrol station. The third one is to recommend an alternate model of petrol station operating process by using simulation.
Next is the method of data collection. Stopwatch method being used for gathering and recording the data needed for activities durations and labeled as events. Events are used to model the start and end activities. From the primary data, it provides us with the data of arrival and service time required for the customers to refuel their vehicle in the petrol station. From the data, the information was inserted into input analyzer as we want to know the distribution fitting of the case data. Input analyzer has the advantage of fitting a wide variety of probability distributions and giving the best result.
Okay, next is the model description. So this figure 1.3 shows the interface of basic simulation model. Second figure shows the interface of animation simulation model, and the third one shows the animated model of a petrol station simulation model. So next we will continue to see our basic simulation model in Arena. We will try to run. So basically in this in this model, we assign each fuel pump with different kind of entity pictures in order to assign them to according to its fuel pump. So So for instance, for fuel pumps 1, we assign the entity picture as superbike. For fuel pump 4, we assign the entity picture as van. And for fuel pumps 8, we assign the entity picture as truck. So we will speed it up a bit to see the results. Okay, so we see the result, and then it shows that the vehicle number out in the system is 143. Okay, next moving to the
Next, we move to animation. In the green box, it shows that the fuel pump is busy.
then we stop, and then we get back to our start presentation. Okay, so first our data analysis. So in order to achieve objective 1, which is to determine the average waiting time of customers at fuel pumps in petrol station, so we gather all the information from the result, and then we put inside a table named table 1.0, which illustrates the average waiting time of customers at fuel pumps. So from table 1.0, it illustrates the average waiting time of customers at each fuel pumps, and this information can widely be used to optimize queue capacity or redesigning the facility layout. So this one we get the citation from Moazami, Galakashi and Kadimi in 2013.
The objective 2, it is to identify the utilization of each fuel pumps and the workers at the petrol station. Table 1.1 shows that the resource utilization of fuel pumps and the workers. The performance of two main elements are shortly discussed in table 1.2. These four elements could be divided into two groups, which is cashiers and fuel pumps. Here is where the manager can profit by the consequences of a simulation display by enhance their staffing and their working hours, upgrade their tasks, jobs, encourage their petrol station with further developed gadget. Furthermore, numerous different occurrences that all will result in better benefit. This is cited by Moazami, Galankashi and Academy in 2013.
Okay, next is the model experimentation. So in model experimentation, we we do two scenarios. So first scenario is addition of another two fuel pumps. So figure 1.6 shows the interface of simulation model scenario 1, which we include fuel pump 9 and fuel pump 10.
Next we move to scenario 2, which additional cashier at the refueling counter. Figure 1.7 show the interface of simulation model scenario 2.
Okay, so in order to achieve objective 3, which is to recommend an alternate model of petrol station operating process by using simulation. So based on the output given for both model scenarios, a comparison has been made in terms of the total production, performance measure, and it shows that scenario 2 gives the best result when compared to scenario 1. It is because we can clearly see that the flow of the total production is being increased by appointing a new cashier to ease the flow at refueling counter. So scenario 1 did not much make any changes that will profit and solve the problem faced by the petrol station currently. Thus, this study recommends an alternate model scenario 2 in order to increase the total production and reduce the waiting time of customers at fuel pumps.
Okay, for the conclusion, there are many advantages to run the simulation compared to really constructing the design and checking it. Simulation is the level of highlight that can be picked up from a simulation model. A simulation shows an outcomes that are not tentatively quantifiable with current existing facilities or technology. The simulation models are adaptable to keep running for the same number of time levels as preferred at any level of failure. Auditing an advantage and disadvantage of simulation modeling, it is important to make reference to that utilization of computer simulation modeling, particularly in the sector of service, is significantly increasing. Last but not least, for our recommendation, the result of comparison show that the scenario 2, which recommend the addition of two fuel pumps and standardizing it to the suitable configuration in terms of utilization rates, average waiting time of customers. So this is our references. That's all from us.
Thank you.
Thank you.